Hi guys, welcome to Adrian's Digital Basement. Now before I start, I don't want you to worry, I am still working on the IBM PC Junior video. Part 2 will be coming very shortly. I'm just waiting for a part on that to finish it up. So stay tuned for that. But today I want to talk about this computer. This is a Commodore 128. As you can see, it's a very, very, very yellow Commodore 128. This is going to be a project for me. I want to see if this A works, and B, I can retrobrite this and make it look good again. Let's take a closer look. Now the Commodore came with the machine itself and this 1571 disk drive. I didn't get a power supply for the computer, so I can't even test it. The yellow condition of this machine is just unbelievable to me. I have never seen anything as orange as this machine, and I don't even think it's really coming across in the camera, but this part of the case up here, it's just unbelievable. Now funny is this top row of keys are completely unaffected by any kind of yellowing, so I guess whatever chemical, as people say it's the bromine, I think, in the plastic that causes the yellowing, I guess these keys didn't have it. This right here is not a sticker, but it probably was a sticker because that's the actual plastic. There's nothing on there. And that's more like the original color of this machine. The logo is in actual fine shape. It's got a little bit of weird kind of bumps on it, but looks fine otherwise. The overall condition, it's a little dirty, but I gotta say it's pretty clean otherwise. There's definitely some shadowing going on these keys here, where there's less yellowing, although these have less yellowing, but these have a lot, so I can't really explain. The 1541, it's pretty bad as well. It's really bad on this side here on the left side. The right side, on the other hand, the right side isn't as bad, but wow, it's bad. But the underside of both the disk drive and the computer look pretty normal. The disk drive also had a label, and this looked like one of those old plastic labels where, you know, you punch the letters into it, and it's been peeled off. I don't know what all these little scratches are around it, but I can almost make out the writing that was on there. Look at the back of the computer, and it's very yellow, but other than that, it looks okay. The yellowing extends inside the cartridge port. It may not be easy to see, but there's yellowing in there as well. The side of the case, same story. Very yellow. But just like the disk drive, the underside is in pretty decent shape. It's a little scratched up and dirty. Manufacturing date is 1085. Now my first order of business before I do any of this retrobrite is I want to see if this computer works. And unfortunately I don't have the power supply. It uses a really weird non-standard connector, which incidentally is the same connector as used on several Amiga computers. But you cannot interchangeably connect the power supply for this with the Amiga. And I have an Amiga 500 with the appropriate power supply for that computer, but it is not compatible with this, and I think damage would occur to the machine potentially if I tried to plug that in. So I need to come up with a different solution. Now I've already removed the screws from this case, and I can take this off. I do have to admit I peeked inside, so this little bag contains all the screws for the machine. And the heatsink / RF shield has already been removed. I did that. And what's exciting and apparent to me is that this is in great condition inside. Yeah, it's a little bit dirty here on the shield, but all the chips are accounted for. Everything looks good. I can't tell for sure if this thing's ever been opened before, but it certainly looks clean. There's a little bit of rust on the RF modulator, so I guess this computer has been, you know, exposed to a little moisture over time. It was probably stored for a very long time. Probably stored directly in sunlight for a very long time. Look here how the vents where the sunlight, I guess, shone through into the case, how yellowed it got there. When I first opened the C128, it had this missing chip, and I was immediately concerned that this was a problem. It's labeled U36 on the motherboard, but after reading about this, that this is actually normal, it's an extra ROM socket that's just not used from the factory. I've removed the motherboard, and you can see the extent of the yellowing. I'd love to hear your comments in the comment section below if you've seen stuff as yellow as this machine. Just for comparison's sake, there's the outside of the computer versus the unyellowed inside of the computer. What really surprises me is this field found C64 was left in the elements potentially for 20 years, and yet was only slightly yellowed. This is post-retrobrite, but this obviously was not left outside. It's very clean, and yet look at this. So here we can see the power connector that the 128 uses, which is a DIN 5. This is a square DIN connector, and like I said before, this is exactly what the Amigas use as well. Now, while the input is not compatible with the Amiga, it is compatible with the C64. And right here, I have my Commodore 64 homemade power supply. So this is a beefed up version that's not going to ruin my Commodore 64s. I 3D printed this case, added an IEC connection here, and I reused the cable off an actual C64 brick. That's what this is here. And this uses a DIN 7, which is round with the pins inside. But the outputs are the same. It has an outputs 5 volts, and this one does it at 2 amps, and it also has 9 volts AC at 1 amp. And that is actually compatible with the 128. So I could easily, if I had a way to plug this into here, well then I could actually use this supply for both my 64s and the 128. So I have an idea, and I need to take the shielding off the bottom of this computer so I can take a look underneath. Oh, there we go. So when I took apart the field found 64, it should have looked like this inside. It should have had cardboard with a layer of metal. And this had rusted away and turned to an ant colony on the other computer. So here's the underside of the DIN 5 square connector on the 128. And it's interesting, I'm just taking a look at how it connects to the motherboard and what the traces look like. And I have an idea. Let me show you. So what I have right here are 2 of the connectors that are used on the 64 and the 128. So this is the square DIN that's used on the 128. This is a brand new connector, it's never been used. And we can look at the bottom pins there and how it connects to the motherboard. And right here we have the Commodore 64 DIN 7. This actually has been used, but it's just what I had in my spare parts bin. And interesting, and it's hard to see initially, but the pin configuration is essentially the same. There's a couple extra pins on this DIN 7 that aren't used, and there are no corresponding holes on the motherboard. But all the pins that are used are actually in the same exact spot. So I found this diagram online. I've drawn these 2 pictures here, which are essentially the underside of both of the connectors, as if they're aligned in the same way. The 7 pin obviously has 2 extra pins over this 5 pin. But interesting is those pins aren't used on the 128 at all. An example is pin 3 right here, which does not exist on this square DIN, but it's pin 3. It's just not connected on the 64. And then there's pin 4, which says not used in this project. This printout was originally for an adapter that someone made externally. Well, pin 4 is this one right here. And that pin is also missing on this connector. So the 2 pins that don't exist on the square one, where there are no holes on the motherboard, aren't even used. Now the rest of the pins are similar, but not exactly the same. So on the 128, essentially we have the 9-volt input on this pin and this pin right here, these 2. Pin 1 there is the 5 volts, and pin 2 is the ground. But on the 64, we got 9 volts there, so that matches pin 6, which matches pin 3. We got pin 2, which is ground, but on the C128, that is 9 volts. Pin 5 here, which is the same as pin 1, is the 5-volt input, and that is the same between both computers. And then we have 9 volts there and the ground. So the ground and the 9 volts are swapped on this. Now, if Commodore hadn't done that, you could literally just desolder this square connector, break the pins off this connector, those extra 2 pins that aren't used, and solder this in directly on the motherboard, and then it would just work. You'd be able to use a C64 power supply. Now, I don't feel like I'm ever going to have a 128 power supply. It's a big brick anyways, and I'd rather just use my 64 one that I've made myself. So I have 2 choices. I can either make an external adapter by buying the male version of this DIN connector here, the square one, and a female version of this, and just making a little adapter, like a little pigtail that plugs in into the 128, and then I could use the C64. And people are going to say that's probably the way I should go. But to be honest, this machine is going to look ugly. I don't think it's really going to retrobrite very well. We'll find out. But It's never going to be a showcase computer. So I'm feeling like I should just swap this connector with the one from the 64 and then cut the traces on the motherboard and try to just rewire it using a little bit of wire to adapt the pins to be in the correct position. So if I wanted to use my C64 and I was going to cut this, I would break this trace right here along there, and I would have to cut around this one right here to isolate it. And essentially this would become the 9-volt input along with this pin, and I'd have to wire a little jumper block between here and here. And this isolated pin here is the ground for the main computer. But I could easily put a little thick piece of wire right here between these two pins to, complete that circuit, and that would take care of it. The only thing I have to worry about is what does the top of the motherboard look like, and are there traces on that side as well? If everything is on the underside here, we're great, because this is really easy to work on. Yeah, I think the first step is for me to remove this connector from the motherboard entirely, and we'll kind of go from there and just see how that works. Okay, so with the help of hot air, my solder sucker, and some fresh solder, I have removed the connector. That's it here. Pretty clean removal, if you ask me. So let's take a look at the other side of the board. I haven't even seen it yet, and just see what these traces look like there. Well, yeah, just as I feared, this is one of the 9-volt pins here, and it does have some ground fill. So I will have to cut this pin as well. So this is kind of a one-way trip, what I'm about to do, but I feel like if I had to, I could repair the damage, as long as I don't mess up royally and scratch the board really badly. So I've snipped off the pins that aren't used, and I actually placed the connector on the board. It's not soldered down or anything, but just to show you that it does fit, it's actually on there right now. So this is the pin that's on the ground plane right here. And this one, it's going to be a tricky one to try to isolate because there's a lot of ground fill on both sides. But I just had an idea. So again, the middle pin is the 9 volts on the 128, but on the C64, so on this DIN connector, that's the ground pin. And if we look here, the middle pin, which is that one right there, is inside the plastic, so it's hidden away. So this pin right here is the ground on the 128, and it's this pin right coming down there on this connector. It's the 9 volts AC from the power supply, but it's exposed. I think I'm going to cut this. That way this pin is just a floating ground right on here. I don't have to actually modify the circuit board. And I'm going to solder a wire directly from here and run it under the board and connect it to the 9 volts. Perhaps one of these pins is big enough to run the wire through. I still will need to cut the trace on the underside of the board. So this top pin is isolated, but I'll have to cut this on the bottom. That way this ground pin is not affecting the 9 volts. And on the underside, I will solder a small wire from this ground to any of these other ground pins there to complete the ground. So that's going to have the minimum amount of modifications on the circuit board. And I will just sacrifice this connector, which is fine. I don't care about that. And it would be easily reversible. There's just one cut trace that should be easy to fix if I ever want to go back to the original connector. Alright, so the connector is just resting inside the holes right now. You see the pins poking through, but notice this ground one is missing. That's because I cut that pin off altogether. And this yellow wire here, which is soldered onto the 9 volts, goes through this hole here, which is a ground hole, so if something shorts out, it's just going to short to ground, which should be safe. It might just make the power supply shut down. And then I've soldered this yellow wire onto the DIN connector, and then I ran it around and through this hole, and I've soldered it here onto the 9 volt feed. So what I need to do now is cut this trace right here, because this is now a ground pin. I need to bridge this pin to that, which will be ground, and that'll float this and keep it separated. So let me do that, and then I'll show you what the other side looks like. Okay, so I have this all soldered up and I have the trace cut. So there's the little bridge I installed to go between the ground pin, which is now isolated. You see I cut right through, and there's actually a relatively wide gap there, of about 1 millimeter. So this is the ground pin, and it's now connected to this, bridged with a piece of metal. In fact, I used the pin I cut off of this pin over here. That's what I used to bridge this together, and I saw a piece of metal. Then this is now connected to the 9 volts, and it goes around to the other side. This is the other 9 volt pin, so these two are 9 volts. And this is the 5 volt input right over here. Okay, and here's the other side. So there's the yellow wire coming out through that hole, and it runs along there, and it's soldered right onto this pin right here. And that pin is cut, so it doesn't go through the circuit board at all anymore. Well, there it is. It's connected to the board. It's on there solid. The pins don't go through quite as deep as they did as the other one does, but it's fine. It's good enough. They still stuck through, and I have a ton of solder on them, so that should not move anywhere. Power switch, reset button. Yeah, it looks good. So what, is this the only 128 with a DIN? I should put this in the bottom case and make sure that it actually works. Yeah, no issues. This connects right up without a problem. Pull this out. Yeah, look at that. Cool. Nice good fit too. Alright, the first thing I'm going to do is we're going to send power into the motherboard. I'm going to keep the power switch off. And I'm going to send power, and I'll measure just to make sure that I'm going to sanity check this. So currently I have the ground clipped onto the shield here. So if I test this ground pin, we're getting continuity. So let's switch this over to volts. Alright, so I switched it over to volts, and we're on DC. So if I turn on the power supply, I should be getting 5 volts DC on this line right here, which is the 5 volt input. And the ground is coming from over here. So let's turn this on. 5.2 volts. Excellent. That's exactly what I wanted to see. Alright, let's switch the multimeter over to AC, and I have both probes here. And remember I said that these two pins right here are the AC input. So if I touch this, I should be getting about 11 or 12 volts AC. There we go. 11.2, 11.3 AC volts. Perfect. So of course, part of it's coming in over this wire right here. Not getting good contact because of the flux residue on here. But if I push down on there, here you go, we're getting 11.3. So the AC looks like it's coming in correctly. Alright, apologize for the noise. I have the furnace on. It's really cold in Portland today. So just as a side note, before I attempted to get the 128 working, I hooked up the Found C64 just to make sure I had my cabling correct. Because I'm using an adapter with RCA cables into a switch box, and the PVM has a bunch of inputs. So to make sure that I can unplug these two cables and plug it into the 128 to see if it works, I recommend you do this sanity check with another computer if you have one, just to make sure all of your components are working, from the power supply to the monitor to the cabling. Otherwise, you could be chasing down issues with the motherboard that are really a cabling issue. Okay, so the 128 motherboard, I'm going to plug the 64 video cable into it here, which is that connector. It's on a different connector. On the C64, it's on the right when you're facing this direction, and it's on the left. And I'm going to plug the power in. The power supply is turned on. Alright, here we go. And we got nothing. Nothing whatsoever. Oh wait. NTSC. Okay, that's a good sign. So we got some kind of a signal there, but no picture. Now I don't know, maybe this is in 128 mode, and I think it's coming out of this 9 pin here, and I have to hold the key down while I turn it on. So let's turn this off and get the keyboard connected. Okay, so I'm holding this a little precariously, and we turn it on. I got NTSC. There's a button you can hold down for 40 columns, so let's... Oh yeah! Oh yeah! So 4080 column is a toggle switch. I hit the reset. There it is. Oh yeah! It works. That is kick-ass. And I think when you type Go 64, are you sure? I am, yes. And then we have a C64. Now it's got lines. It's got lines. That's just a problem with some of these Commodores. Other of my C64 has these vertical lines that kind of go through each character. And I don't have that on the Found one, but the other ones do. And this 128 does as well. But look at that! It works. So if I hit reset, it should go back to 128 mode, 128K bytes free. Thumbs up! Well, there you go. I have a working Commodore 128, and it was all possible by me swapping the power connector over from that ridiculous square DIN, which is really hard to find and expensive, to a really common DIN 7 that happens to be the same pinout as the Commodore 64 now. So I can use my really good power supply to run this computer and to run my C64s, and I just won't have to worry. I clearly have a lot of work ahead of me though, because this thing needs some serious restoration, at least from a retrobrite perspective. So this is really going to put to test my new retrobrite process where I use that box with the blue light. Check out the description for the link to the other videos where I show off that process and how it works. But we're going to see how well it works with this. I'm going to need to scale up a little bit so this will fit inside the box, 'cause it's not quite big enough. But it'll be really interesting to see how this turns out. So I hope you found this video interesting. I'd appreciate a thumbs up. Feel free to put your comments in the comment section below. Of course, you can subscribe for more videos. And thanks for watching. Bye.